So first, how do engineers they calculate the shed? You send the shed to them. Hey, I have a shed that's 10 by 15, 4 meters high. I need you to calculate the frames for me. So the first thing that engineers do is we go to a program. It could be robot structural analysis, it could be space gas, it could be SkySieve, or many of the systems out there. And we start by defining the portals, like the geometry, and we define the supports. So for example, if it's going to be fixed or pinned, remember we discussed this already. Then we apply the loads. So the loads that we apply are the self weight of the material. We call it dead load. It's a dead load. And we have the live loads. So just simplifying here is imagine someone walking on the roof, for example. So we need to consider that. So the shed won't fail if someone decides to walk on the roof. And then we have our wind loads that they're generally the more representative ones. And depending on the shed, we have the snow loads and etc. Once again, don't panic looking at all of this. I hope you can understand the principle. I don't want to be very technical on this presentation. So we're going to have these load combinations. That's pretty much saying, hey, I have the self weight of the material, I have someone walking on top of it, and I have a wind. So when I sum actually those three different loads, I have what we call load combinations. So the code will give us some formulas to do that. But this is the first step. Once we have this, we run the structural analysis. Once again, there's a lot of mathematics involved here. I don't want to overcomplicate, but we use specifically in Shedmate what we call a finite element analysis system that will give us all of the internal forces, displacements, and support reactions for that specific structure. So for example, here you can see there is some momentum, there's some different forces applying. And you can see here, this is kind of a graph, right, guys? So the larger ones means there are more forces here, and the smaller ones means, hey, they're not very strong forces here. So we'll calculate based on the stronger ones. And on the other side here, we have displacement. So you can see that in red. So that shed will have some sagging, there's some displacement that will happen, and we can identify based on these calculations how much that's going to be. So when we do this, then we go to the next step in which we can get the loads. And once again, if you are an engineer listening to me, you might say, oh, you're skipping a lot of steps. Yes, I don't want to overcomplicate. My goal here is to just present this to shed business owners in a way that can be easily understood. So when you get all of those forces and the displacements, then we can assess these in different ways. One, we could check against ULS, which means ultimate limit state. So think of it as a safety check. It makes sure that your shed won't collapse under extreme conditions like strong winds, heavy snow, or maximum loads. So this is all about strength and stability, proving the shed can hold up when it's pushed to its limit. This is the first check. Another check would be the SLS. This is Serviceability Limit State. So this is the usability check. So my shed will still be there. It won't collapse, but I don't want it to, buckle too much. Remember? So even if the shed won't collapse, you don't want it to bend, deflect, or crack too much under normal usage. SLS ensures the shed looks right, works properly, and lasts without issues such as sagging roofs, rattling cladding, and doors jamming. And then we have the footing verification. So the footing verification is pretty much the uplift, so we can define how big your footings are going to be. So this is what we do. We pretty much coming back here. We define our loads, we define the structure, and then we run the structural analysis. We look at the results for every single item. So we look at the columns, the rafters, the mullions, the purlins, the sidewall girts, and we check, is it making sense in terms of the ultimate limit state and serviceability limit state? If it is, great. In this example here, as you can see, my end wall girts didn't pass, right? Say, hey, not okay. You need stronger ones, otherwise this is gonna fail. So what do we do? Guess what? We start all over again. We change those girts and we do the same thing again and again, and then we get another result. So there's a lot of iterations that happen here until we find the right solution. So understanding this, then you might start to understand that's not as simple when you send a design and say, hey, engineer, tell me what are the frames. The engineer will send something for you, and then you come and say, hey, you know what? Can I change the columns to something else? The engineers will be like, if it's stronger, yes, make the change. But if it's not stronger, yeah, you could, but I would need to redo this. I would need to go back to my program. I would need to put those items again, and I need to assess these, and I need to make sure that displacement, everything is correct. So are there ways to do this? Yes, but it's generally a time-consuming process. And because sheds, they are not a, a engineering project that's very expensive for the charges of the engineers, generally speaking, they become the bottom of the list. They are not the top priorities. The structural engineer might be working with a bridge, with a skyscraper, with an industrial project, and then when it comes to this little shed with all of this back and forth, it's just like, oh, that's a pain. And this is when that conflict starts to happen, because the shed business owners, they might not know necessarily what assumptions to tell the engineer in the first place, and the engineer just wants to get it done, and they send the report, and these guys come back, and all of that back and forth, and it becomes chaos. Okay, so to shed business owners out there, what I would say is, look, as you can see, this is not as simple as just doing this and you have your frames. You could have your Excel spreadsheet. Some engineers do do that, and they can change a few numbers, and they can have a good understanding about what was the outcome for that specific shed design. But if they want to do it everything right, they need to follow a process, and this process is not straightforward. So it requires time, right?